We are the Harmonic Vibration Feedback System Senior Design Team working with NavAir. NavAir was having significant chatter with one of their parts. Our main objective of this project is to design a system that will measure a workpiece's natural frequency and tell a machinist what spindle speeds to stay away from in order to avoid exciting the natural frequency during machining. Thin-walled aircraft components often experience significant vibrations during machining. This causes chatter and decreases the quality of the finish. To avoid chatter, a machinist must avoid spindle speeds that would excite the part's natural frequency. These are the requirements and capabilities of our system for this project. Our design will accomplish each one of these specifications upon its completion.
Here is the ANSYS model we use to calculate the natural frequencies of our part. The operator does not want to excite any of these listed frequencies while machining. We chose a signal conditioner that samples 48,000 per second, which is suitable for measuring this part. This is the wiring diagram of our whole system. The accelerometer and impact hammer are connected to the signal conditioner. The signal conditioner is connected to the mini ITX computer, and the operator views all this information on the LCD screen. These are the steps we implemented for waterproofing our designs, starting from coating the accelerometer in silicone conformal coating or clear nail polish, and ending with covering the attachment wires with tape to avoid movement during machining.
Topics under the design features are some specifications and information for the wax used in the accelerometer, such as the weight of the accelerometer has no impact on the vibrations of the part. The positioning of the accelerometer is important to avoid the windmill, and make sure that the appropriate coolant jet is repositioned to avoid any direct blasts to the waterproofed accelerometer, which will knock it off. For the next semester, we will need to modify the LabVIEW program found to translate the frequency response function data into spindle speeds, so that the operator of the machine can avoid that RPM.
This is a list of the components we'll be using in our project, including the accelerometer, impact hammer, and the end mills. Here you can see a 3D model of our testing setup. The roughed part will be placed on 10-degree parallels, and the accelerometer will be placed on the inside of the part. This setup allows us to replicate our sponsor's 5-axis toolpath on a 3-axis machine. These pictures show our toolpath used for roughing the part on a 3-axis milling machine. A 3/4 end mill will be used to remove most of the material, and a 5/16 end mill will be used to mill the corners.